Hello.
Oh, sweet. Yeah, so my name is Neil Kimmett. I work for Harry's. We are a razor company, and there's some of our beautiful razors there. And this is a Swift introduction. So what is Swift? You might know it as that language your mobile developers write. It was introduced in 2014 by Apple to kind of supersede Objective-C, which is what we used before. And it's easy to forget at the time. That was quite shocking. Hopefully the audio is going to work. This is when they introduced it. Oh no, the audio is not working. So here, Craig is saying, what would it be like if we had Objective-C without the C? And then there's a bunch of excited mobile developers, there's some murmuring. And then he says, we did more than that. We have a new programming language. And then, whoa, there's a bunch of super excited Apple nerds. And then he says, it's called Swift. Oh, it's called Swift, and it totally rules. Yeah, there we are. That's actually how they introduced it. It does totally rule. So let's dive into some Swift. We're gonna go through a lot of code today, so strap in. Here's a function declaration in Swift. You have the func keyword. The name of the function is move. And we go from start, which is a point, to end, which is a point, and then we return a distance. So two things you'll notice here. Types, there's types everywhere. Swift is a compiled, statically, strongly typed language, which is great, because if you try to pass the wrong type of thing into the wrong function, the compiler won't let you, which is fantastic. The second thing you'll notice is there's two names for each parameter. We have an external name and an internal name. We have from start and to end. So you'll use start and end within the function, and from and to outside the function. So the idea being that you read at the call site, we read it sort of like a sentence. You go like thing, move from here to there. Let's look at some more Swift. So here is a list of names, a list of strings. And we can do functionally sort of things using map. Functions of first-class citizens. This is a little anonymous function here. We can map over stuff. But really, the only interesting part of this code is the appending is super cool bit. Then we have a lot of redundancy here. We have a lot of repeated types. Thankfully, Swift has this powerful type inference engine. So on the first line, the compiler can tell that on the right-hand side, we just have a list of strings. So this bit here can go away. And on the second line, it can tell that it's being passed a list of strings. So we don't need this type annotation here. We can also use trailing closure syntax to get rid of these brackets here. And we can finally use shorthand argument syntax to get down to just this. So it almost feels like you're just writing a nice scripting language, but behind the scenes, there's all of these strong types. So now I'm going to sort of take you on a tour of different kinds of types in Swift, and we're going to build this system where we ask for a user's date of birth, and then we tell them if they were born on a weekend or not, and kind of sketch through it. So we're going to start with our person class. So we have classes in Swift, like most object-oriented languages. A class has properties. So we have, or instance variables. We have var, name, and let date of birth. What's going on there? So var means you can mutate it. Someone could change their name at some point in the future. A let is a constant, which means you can't change the value of it. You couldn't change your date of birth. That doesn't make any sense. So it has an initial value, and then that's the value the whole time. So Swift has a big focus on immutability. So we need to give it some initial values. So we have an initializer, where we just pass in some initial values. And then we can define functions on classes that do some stuff using those properties. So classes are reference types in Swift. So that means as you pass it around your system, and more references are made to it, the reference count of that instance goes up. And then once all the references are gone away, once bits of the system don't care about it anymore, the reference count goes to 0, and the object gets deallocated. It's not garbage collected, it's reference counted. There's also value types in Swift. So reference types are great for things which have identity, like a person. You're not going to copy a person, that doesn't make sense. But for things which are just more data-like, and you want to be able to just pass between threads without like race conditions or anything, we can use things like structs. So we're not going to implement dates, because that would be mad. We can implement a date formatter. So we're going to do this as a struct. We're going to give it a format string, so like YYYMMDD, whatever. And then we're going to have a function on it that when we get a user's input, which is this string we're going to pass in, we try to get a date out of it. So say we get down to implementing this function. At some point, in some cases, we're going to want to return nil because the user's typed in garbage. It doesn't make sense as a date. Unfortunately, the Swift compiler won't let us do that. Why won't it let us do that? It's because the return type here, date, is non-optional, which means it always has to have a value. It can never be nil. How do we make it optional so that it could be nil? We throw a big question mark on the end. Not necessarily that big, that's for a fact. And that means the value can be nil. So this means you have to really reason about the parts of your system that can be nil and explicitly mark them as being able to be nil. So things that talk to the network, things that read things from disk. And other bits, you can have this juicy core of non-optional types, which gets rid of this whole class of bugs. It's sweet. So let's start putting some bits together. So we're going to get a user's input. They're going to give us their date of birth. Then we're going to make a date formatter object with the format of date we expect. We're going to try to get a date from what the user's given us. It's maybe a date, we're not sure. And then this is the main way we deal with optionals in Swift. It's called optional binding. We do if let. We have a new variable name. We bind a new variable name to our optional variable. And then inside these curly braces here, we definitely have a value for date. There's other ways of dealing with optionals, but optional binding is kind of the main one. So we move on to our final type here, the day of week type. So this is an enum, which is for things which are kind of mutually exclusive. It's like a sum type in type theory. So we have case statements, one for each day of the week. And then, as with all of our other types, we can just define functions on them. So we have a switch statement that, like, if it's Monday through Friday, it's not the weekend. If it's Saturday or Sunday, it is. And now we can put this in here. So we have our maybe date. If we do get a date, then we can make our person object. And then we can query our person object. Their day of birth is at the weekend. So that's a very quick run through the sort of basic syntax of Swift. There's a lot of more complicated bits. There's generics. Enums can have associated values. There's protocols which you tie sort of bits of behavior across types, common bits of behavior. But that's hopefully enough to whet your appetite. What if you want to learn more? So Swift was open sourced in December 2015, which was quite big for Apple. So you can go to GitHub, dig through the mostly C++ code base, but all the standard library is in Swift. The most interesting part of this is there's this Swift evolution repository. So anytime someone wants to make a change to Swift, they have to write up this detailed sort of design document saying why they want to make the change, the impact it's going to have on existing code, because there's a lot of existing code out there. And then the community will debate it, and it'll get accepted or rejected. So you can go to this repo and see this chronological list of all the different proposals that have been made and the ones that are being made for Swift 4, which will be coming this summer. And then another very exciting thing that came out of Swift being open sourced is it runs on Linux, so you can have Swift on the server. It's not just for mobile apps. So there's two big web frameworks. Kitura is written by IBM. Vapor is this community effort. So you can go out there and write a web app in Swift. I know of companies that have little microservices running Swift in production. Why would you want to do that? It's a little bleeding edge. So Swift is a compiled language. It has really great performance characteristics. So if you're doing a bunch of number crunching and you have a bunch of mobile developers on your team, you could just get them to write your little Swift microservice. And one thing that I think might be quite cool is you could write, say, the model layer of your application as this library. Then you could include it in your iOS app. You could include it in your server app. And there's a whole bunch of duplication there that you've just gone away like magic. So yeah, go and play with them. They're really cool. And that is all I have time for. You can check out Harry's at harrys.com, or you can download our app on the App Store. Thank you.